The focus of today's lesson is properties of trapezoids. We'll start with some definitions. A trapezoid is defined as a quadrilateral with exactly one pair of parallel sides. You'll see here in the image, BC and AD are parallel, whereas AB and CD are not. If we extended them, you would notice they would eventually intersect. The parallel sides are called the bases. So BC is a base and AD is a base of the trapezoid. Now, the base angles are the angles that we see that are consecutive who have a common base. These B and C are base angles for side BC, and then angles A and D are base angles. In trapezoid ABCD, angles A and D are one pair of base angles, and B and C are the second. Now, the non-parallel sides are called the legs. So in this case, AB and CD are the legs of the trapezoid. Now, if the legs of a trapezoid are congruent, then the trapezoid is said to be an isosceles trapezoid. So if this length here and this were the same, we would call this isosceles. And it would look something like this. All right, example 1. Show that ORST is a trapezoid. Then decide whether it is isosceles. All right, let's start by verifying the first requirement, which is parallel sides are bases. So looking at this image, it appears that RS and OT are parallel, but we must. All right, so let's take a look at those slopes. So the slope of RS is rise 1, run 2, so slope of 1/2. Then the slope of the other base, OT, is up 2 over 4, which reduces to 1/2. We notice then that RS and OT have the same slope, so we can say these are parallel. So RS is parallel to OT, which is our first condition for it to be a trapezoid. And actually, our only condition. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. We have here one pair of parallel sides. So this is, in fact, a trapezoid. So first thing, show that it's a trapezoid. We did. So ORST is a trapezoid. Right? One pair of parallel sides. Now we want to determine if it's isosceles. Now, an isosceles trapezoid is one that has legs that are congruent. So we want to figure out how long this side is versus how long this side is. If they are congruent, we will say isosceles. Now let's start with RO. And it is, using the distance formula, x2 minus x1 squared, so 0 minus 0 squared, and then 3 minus 0 squared. That is 0 squared plus 3 squared. That is 0 plus 9. That is root 9 or 3. Now, when you look at the picture, you see that it makes sense. 1, 2, 3. Now, let's find ST. So ST, using our distance formula, is 4 minus 2 squared plus 2 minus 4 squared. That is 2 squared plus negative 2 squared. That is 4 plus 4, or root 8, which is not 3. So this is going to come out, I don't know, maybe like a 2.8 or a 2.9-ish. Okay, so about 2.8. Now we could ask a calculator. Let's just make sure and see. Yeah, about a 2.8. So those are not congruent, so this is not isosceles. All right, now it's your turn to try. The points A, -5, 6, B, 4, 9, and C, 4, 4, and D, -2, 2 form the vertices of a quadrilateral. Show that ABCD is a trapezoid, then decide whether it's isosceles. Pause the video, give it a try. Now that you've finished try this, compare with the neighbor, see if you got the same thing. Then grab the practice worksheet and knock it out.